Hello everyone, welcome to my channel AWS Solutions Hub. Today we are going to see another session on Terraform. Today I will explain you what are the different files and directories Terraform creates by default, and I will show you what are the different ways you can declare variable files in Terraform. Okay, so we'll go one by one. So I'll explain you through the Visual Studio Code also what all different files that has been created. If you haven't watched my last video on Terraform installation, where I have explained you how to do the installation of AWS CLI, Homebrew, Terraform on Mac OS, and at the explanation of those, I created one Terraform workspace. Okay, so if you haven't watched that video, I'm giving you link here. Please do watch that video and please come back here so that you feel not lost in this video. Okay, so I'm using the same Terraform workspace that we created last time to explain and to go through this slide. Okay, so on this slide, our first point says .terraform directory. So when we run Terraform init, okay, so if you recall, last time we ran three Terraform commands: Terraform init, Terraform plan, and Terraform apply. So when we run Terraform init, Terraform identifies the required providers. Again, we had mentioned the provider section where we said provider is AWS. Okay, so Terraform identifies that required providers and download the appropriate plugin binary from the registry, and these binaries are stored in this .terraform directory. And this .terraform directory, it is located at the root of the project. Okay, so let's go to our Visual Studio. So this is the Terraform workspace we created last time, and you can clearly see there is .terraform directory. Okay, under there are many folders are created, but you can see under .terraform there is providers, then registry, HashiCorp, AWS, then there is 5.83.1, which is the AWS version. It has been downloaded. Since we did not mention any version, it has downloaded the latest version that suits this platform, and the last slash is the Darwin ARM64 is the platform. But this is the .terraform directory. If we go inside this, you can see it has downloaded the provider. Okay, as per the explanation, Terraform identifies the required pod and downloads the appropriate plugin binary from the registry. Okay, so it has downloaded the AWS binary. Okay, and that sits under the .terraform directory. Next is .terraform log.scl. The .terraform log.scl is a file generated by Terraform. It maintains the hashes of the download binaries for consistency and tracks the provider versions used in your configuration. We do not interact with these files directly or manually. They are maintained automatically by Terraform. However, you should commit the .terraform log.scl file to your version control system. And why is the last statement? Because if you're as it is said, like this holds the all the information that we have given as a part of provider, and whatever it downloads, it keeps it in the hash format. Okay, and if you do not put this file in your version control system and you're deploying the same configuration in dev or in production, there are chances that your configuration will mismatch. Then in dev, int, and production, it will try to download the latest version which may be different from this one and try to create the another log.scl. But if you commit the terraform .log.scl in any environment, it will keep the same version that your testing environments also, or your sandbox also. In sandbox you usually do the testing, and you want to have the same version on which you have done the testing to be deployed in dev, production, or testing environment, right? So that there is no misconfiguration between your sandbox and the subsequent environments. And that is the reason it is a best practice to push terraform.log.sl file. And this is created again when you do the terraform init. At the same time, this file is created. So if you tomorrow, if there is new version is released, and during the terraform init that version has been released, this file will be automatically updated by the terraform. Okay, as it is said, manual edits may be lost in future updates because this is maintained by terraform. We do not maintain this. Okay, so no need to touch this file, but it is a good practice to push this file in your version control system to maintain environment configuration consistently throughout the environments. Next is Terraform TF state. This is the Terraform state file which is critical, yes, and automatically managed by Terraform. This file is either managed locally, that is default backend, or remotely when working in teams. The remote backend should be used. Okay, what it is saying, it is talking about this Terraform state file. Okay, basically you can treat Terraform state file as your blueprint, or instead of blueprint, you can say it is the actual representation of your running infrastructure in AWS. Okay, uh, it creates a JSON file. Okay, so whenever we change uh, in our AWS cloud environment, all the changes are depicted here. For example, you have multiple TF files. You have created vpc.tf, securitygroup.tf, and you have deployed that infrastructure. So whatever is happening in your cloud infrastructure, what all resources, configurations are getting deployed to your AWS cloud environment, the same will be added to your terraform.tf state file. And Terraform uses this file, okay, to manage your complete infrastructure and configuration. Tomorrow you introduce a new EC2 instance or any new service or resource, Terraform checks whether that resource service is present in Terraform tf state file. If not, it will add it. Okay, and if it is there, it will try to update it. Okay, so every time you do the changes, this is the file get Terraform refers and updates the configuration on your AWS cloud. So that is the reason it is very 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 critical to maintain this Terraform TF state file. You need to keep it at securely. You need to keep it securely somewhere. Okay, so if you run just like me, I'm running the terraform locally. So it has created the Terraform tf state file within the same workspace, but you can move this file to any secured place. Just like um, there is one provision Terraform does, that you can push this file into S3 bucket. Okay, how to do that I will show you once we go through all files. Okay, but remember, in our description it is said remotely. Okay, this file is either managed locally, which is here when you don't mention any configuration for backend. Okay, the file is stored in your workspace locally, which is not secure way to keep your Terraform state file in actual production environment. Or remotely is the right way to keep your Terraform state file secure, and apply versioning on the S3. Because tomorrow for some reason your environment gets disturbed, then you can go back and pick the old running version of Terraform tf state file, and you can deploy the infrastructure. Okay, so it is again a best practice to enable versioning if you are storing your Terraform tf state file in S3. You can store it on Azure storage or any Google platform. but since we work on AWS, it is suggested to go for S3 and DynamoDB. Why DynamoDB? Because you want to apply the locking mechanism also to avoid the race condition, so that no two users concurrently updating the same Terraform TF state file. This concept we will look into subsequent Terraform sessions. Today's session is mostly just go through the file and directory structure for Terraform. Okay, then there is something called the Terraform tf state log.info. Terraform implements a locking mechanism, and that helps avoid race conditions and prevents state file corruption. Just now we talked about S3 and DynamoDB, but if you are not configuring S3 and DynamoDB and you have a local configuration just like me, then Terraform, what it does, it creates a terraform.tf.log.info file when you are running a plan, apply, or destroy command. Okay, the locking mechanism depends on the type of backend used. Yes, exactly. In case of the local backend, which is in our case, this log file managed using an additional file that exists for the period of operation, plan, apply, destroy being performed. Once the operation is completed, the file is removed. Just to show you, okay, right now you cannot see it because we are not performing any of the plan, apply, or destroy. The moment I say Terraform plan, you will see Terraform tf state. Okay, and since the operation is completed, that file has gone, but for the short period of time you could have seen it was there. So if I run it again, you can see log info, that file is gets created. When you are doing apply, the file will stay there until unless the apply changes are completed. So this is the locking mechanism when you have Terraform state file locally. Okay, whereas if you have a backend, there is a different mechanism which you need to combinedly do with AWS S3 and DynamoDB, which I will explain in later sessions of Terraform. Okay, the next file is .terraform.tfstate.backup. Okay, as the name suggests, you might have guessed it rightly. The .terraform tf-state backup file is important because it allows you to recover your infrastructure state if your original files are lost or corrupted. It also helps you detect difference between desired state and the actual state of your resources. Okay, so this is the backup file. Okay, if you can see, last time we created the AWS instance, it is keeping it has kept the those old information. Okay, but basically it is the backup of the Terraform state file. Okay, as and when you do the changes in Terraform state file, this holds the last version of that Terraform state file. And as it is said, okay, it is detect the difference between your desired state and actual state of your resources. When you run the plan and apply, it takes the reference of the backup file, okay, and give you the result. Okay, all right. Okay, then comes the concept of tf force file. Okay, in our Terraform workspace, you can see .tf. Okay, but you do not see the tf force file anywhere here, right? So this is a special type of file where you create the variable. Basically you declare the variable inside this uh, .tf wars file. Okay, it allows us to manage variable assignments systematically in a file with the extension tf-force or tf-force.json. This is a special extension. Um, tf-force is different from .tf file. Okay, what we have, like we have main.tf, it is different from the tf-force file. Despite the fact that there are numerous ways, yes, we will see those numerous ways to manage variables in Terraform. tf-var files or tf-force files are the best and most common way to do so due to the simplicity and effectiveness. That's correct. So as it is saying, there are many ways you can manage the variables in Terraform, and that is what we are going to see in this session. Um, but this is the most simplified and effective way of managing the variables. So what are the different ways you can manage the variables in Terraform? Okay, different methods to declare and use variables in Terraform. Okay, so we will see one by one, and we'll see the demo also. Okay, let's do it that way so that you can relate what I'm saying here. So first says variables dot tf. Okay, define any name dot tf file. Okay, it is not mandatory to keep file name as variables. You can give any name with dot tf extension, but it is again the recommended way of declaring your files. Okay, so variables.tf, and declare variable with type and default value as optional. Default value is optional, type is mandatory. Pass values using hyphen var and the name of the variable and value. If no value is mentioned, then default value is used. Okay, do not get confused, I'll explain you here. Maybe I need no need to even run the uh, actual, basically no need to deploy the infrastructure. Without that, I also I can explain you. Okay, so as you can see here, I'm trying to if you don't understand this, don't worry, we will see this everything in upcoming sessions. But basically what we are doing is we are creating a EC2 instance with given AMI ID and given instance type with tags name as hello world. Okay, and you can see here instance type says t3 micro, which I have hard coded, correct. And which is not the ideal practice in programming languages. So what do? We need to parameterize it. Okay, so what we can do, as per the first approach, we will create variables.tf. Okay, after creating it, what you have to do is, okay, this is the syntax how you declare the variable name of the variable, instance type. Okay, this name is a logical name. This can be anything. This does not have to match with this. Okay, it can be anything, but again, recommended way it is to go with the similar name. Why? Because when we are referencing it, you will see why I'm saying that. Okay, variable is instance type. Okay, there are two things. One is type. Okay, which you can say, sorry. Okay, let it be. I will not correct this on my own. Okay, there is a special command in Terraform to format files. I leave it as it is so that I can explain you the formatting also. Okay, the type is string. Okay, uh, then I'm giving it a default value. Let's say t2 micro. Okay, and if you want to give description, you can testing variable mechanism. Okay, so I will save this. Okay, here what we have done, we have just declared a variable, we haven't used it yet. Okay, so how can I use it? I have to go here. Okay, I will, okay, I will comment it so that just for for reference how it was before and now how it looks like. So when you do var dot instance type, and that is how it is referred. Okay, so when you say var dot instance type, anywhere in your configuration, okay, it goes to the variables.tf. It looks okay, there is a variable called instance type and it has a default value t2 micro, it will pick it up. Okay, um, yes, if you this name, this instance type, has to match with this is referring this variable. Okay, but need not to be exactly like that. I mean, I can declare this variable as this also, but this has to match in the variables dot tf. Okay, hope you have understood the references. Yep. Now we have variable declared and variable used. Okay, let's try to run a Terraform plan. And previously it was showing T3 micro. Okay, but there is a default value we have given. Okay, so it will use that. Okay, if we see the instance type, as you can see, instance type is T2 micro, and where it is referred from, it is referred from the variables.tf. But what if I want to use um, T3x large? Okay, how I can do that? Now there is a default value, but I want to provide a different value to this variable. Yes, you can do that. You need to override it. How you can override it? Terraform plan hyphen var, okay, equal, in bracket, instance type equal T3, suppose x large. Yeah, hopefully the we have mentioned hyphen var and in code, that's how it is saying. So let's try this. Okay, it's working, and you can see it is saying now T3 x large instead of T2 micro. Okay, so that's how you override the uh, default value. Okay, but just imagine, I mean, we have just declared one variable. Okay, and that's there are and um, we are, if you want to override that value, we have to pass it as an argument. Okay, to that command, Terraform plan command, correct? But imagine if we have 100 variables, 1000 variable, that is a practical scenario. I mean, you parameterize everything in Terraform. Okay, and the more you parameterize, the more variables you will have, and managing that through arguments, definitely it's not an easy job. Okay, so we have a different way of managing the variables. Let's look at the second way. Okay, what it says, vars dot tfvars. Okay, define any name dot tfvars. Again, vars is just a name. It can be any name of your choice, but the extension has to be tfvars file with all values that you want to use in Terraform configuration. Helpful when you want to define different values for different environment configuration. For example, dev.tfvars, production.tfvars, while running Terraform command mention. Okay, while running, you have to mention it like this, hyphen var file and the name of the file. Okay, don't worry, again I will explain you everything here, what it means. Okay, let's change the same file. We'll rename it to, I'll keep the variables it as it is. Okay, just changing the extension to tfvars, variables dot tfvars. Okay, okay, I did not explain you the how to do the formatting, you right. Let me show you the Terraform format. So when you do Terraform format, all the files inside your current workspace all will be formatted. Okay, it says, just a second, I guess it's Terraform format itself. FMT. Okay, I, instead of format, I have to use Terraform FMT. Okay, as you can see, it has automatically formatted which files, main.tf and variables.tfs. Okay. Okay, so how to implement now the TF wars is something we'll see here. So we already have a variables.tf. Okay, we'll leave it as it is. We'll create one more file. Okay, we'll name it as let's say similar to create a file vars.tfs. Okay, uh, now you have two files, variables.tf and vars.tfs. Okay, and this is where you can say instance type equal t2. Okay, what is the current one? What is default value? T2 micro, right? Let's give it something r3 x large. Okay, let's go it this way. So now you have one more additional file called vars.tfs. Okay, the how execution goes. Okay, Terraform comes here. It looks okay. There is a reference var.instance type. It goes to the variables.tf file. Okay, and here it says okay, instance type variable is declared with a default value. Okay, and it will try to use the same default value here, but if you want to use value from the tfs, okay, that is something we'll see how it is done. Okay, so normally if I run the Terraform plan, okay, without any command argument or parameters, it will take the default, which is t2 micro. It is taking t2 micro, correct? But let's say now I want to use the value from tfs file. So var file, what is the name of your var file? vars.tfs. Okay, I guess you need to give equal. Let's try it out. Otherwise we have to remove that equal. Yeah, it is the extent, the syntax is correct. Okay, and now you can see it is using r3 x large. Why it is using r3 x large? Because while running the Terraform plan, I mentioned use the variable value from vars.tfs. Okay, the extension, the syntax goes like -var -file equal name of the file where you want to refer it from. And in our presentation it says, okay, helpful when you want to define different values or different environment configuration like dev.tfs, production.tfs. Okay, what I mean by that is, okay, if I rename this, okay, let's say it is, and you have two environments, dev and production, let's assume that way. So what you will do is you will create two tfs file. Okay, dev.tfs, production.tfs. Okay, I will copy the values from dev.tfs to production.tfs. Just here I will just say m3 x large. Okay, so for example, in dev environment you want to spin up an ec2 instance using r3 x large, and when it goes to the production environment you want to use the m3 x large. Okay, so how we will do it? So instead of var.tfs, now let's say I'm running this in the dev environment, so I will refer the dev.tfs and it will pick up the r3 x large value. Okay, but now if I'm running this into production environment, okay, I have to just simply say prod.tfs and it should pick up m3.x large, and you can see it is picking up the m3.x large. Okay, so that's how you differentiate the variable values between the environments. Okay, so you don't need to change or don't need to touch your main tf file where you are creating ec2 instance. You are just manipulating the value through prod.tfs and the dev.tfs. Okay, so this is helpful when you have multiple environments and you want to manage the multiple environment configuration, okay, through tfs with declaring one single template of your infrastructure. I'm not changing the template, I'm just changing the variable files. Okay, now the third way, it says terraform.tfs. Define exactly the same name if you want to load the variables file automatically. Okay, this is the way. Now if you see while running the while running the Terraform plan, I was saying I was giving the parameters here, right? Where hyphen file, or even in our previous example of variables.tf, I was giving hyphen var. Okay, but what if I want to have, like, I want Terraform to load my variable file automatically, no need to mention anything. This will be picked up and variable values are replaced on the go. Okay, so how I can do that? So you need this variables.tf again, but uh, you need to use a specific naming convention here, that is terraform.tf first. Okay, so what Terraform will do is, while running this configuration, it will automatically load this terraform.tf first file, and it will take the value from here, where you don't need to mention anything on the command line. Okay, let's try it out. Terraform, I'm not mentioning anything, leaving as it is. My assumption here is it should pick m3.xlarge. That is what in the terraform.tf first. Let's see. Okay, it has picked up m3.xlarge. Correct. It has automatically loaded this file and it has picked up the m3.xlarge. Okay, now suppose, is it mandatory to use the terraform.tf first as the name? No. Okay, and that is the next mechanism. Okay, where dot auto dot tf first. Okay, define any name dot auto dot tf first. Sorry, there are two dots here, but it's a single dot. So there is, you can give any customized name dot auto dot tf first file to load your custom file automatically. No need to mention anything while running the Terraform commands. It's a way if we have a different variable files. Okay, yeah, again it is going in the same way. So suppose you have declared the multiple configurations for multiple environments. Okay, now you want to automatically reload the files. Okay, uh, okay, let's say dev.auto.tf first. Okay, I want this file to be automatically loaded for the dev environment, and this configuration holds true for the dev environment. Okay, current Terraform files are for the dev environment. Okay, what I can do, I will just do Terraform plan as it is. Okay, I'm changing the value so that you will not feel uh, whether it is taking the last result or what. I will go with c5 large, c5 large, c5x large. Okay, let's do it now, and you can see it is automatically picking up the value from dev.auto.tf first. Okay, now your question will be, I mean, there are many ways, and I can see here variables.tf, dev.tf or dev.auto.tf or how Terraform understand which value to pick up while executing the commands. Okay, so there is a variable precedence, it is followed. Okay, so what it says when you declare hyphen var or hyphen var file. Okay, so as this way, like hyphen var file, or there is one more, or this hyphen var, this takes the uh, most precedence out of all your definitions. Okay, the first is hypervar and hypervar file, then anything with auto.tf first. Okay, that will be picked up. All right, and if you have then the Terraform tf first take the precedence. Okay, if you want to try it out, let's try it out. We'll create one more file, terraform dot tf first. Now we have auto.tf first and terraform.tf first also, but it should pick up, I'll declare it as m5 large or m5x large, let it be. So since I have terraform.tf first and dev.auto.tf first also, and as per our documentation, auto.tf first takes the precedence over terraform.tf first. Let's see how it works. Okay, I should again see the value from dev.auto.tfr, that is c5 x large. Let's run, and you can see it is taking the precedence of auto.tfrs over terraform.tfrs. And at the last, the environment variables, it has the lowest precedence over the all other variable declarations. Okay, so that's how Terraform works. Variable declaration Terraform works. Okay, there are different ways to declare the variables in Terraform, but every declaration has its own significance, like pros and cons. Um, but recommended way is to go for the TF first. Okay, where you will declare the every TF force file for your every environment, and you have to automate a way as such that it picks up when you are running the Terraform script into dev. It picks up dev.tfrs. In a similar way, if you are running the same infrastructure in production, it will pick up the prod.tfrs. Okay, I thought of explaining how to create EC2 instance, uh, but I thought of again I will create a one separate video from how you declare it, what are the different ways to mention the backend files that we discussed. Okay, in our previous slide, if you remember, how to store the Terraform TF state file remotely. Okay, so I will explain everything in my next video. Okay, so please do subscribe to my channel so that you will get notified when I'm uploading new videos. Okay, and thank you for your love and support again. um, so see you in the next video. Thank you, bye.